Okay, we have 2 examples left. I backed up on 11 because we're going to have to redo it again. But 11, 12, and then you just have homework from there. So, 11, this is on 5-3. 11, we said u was this chunk right here, x minus 1. Then the derivative of u is du, the derivative of x minus 1 is dx. 1 dx, okay? I leave the 1 off. All right, now we start to substitute. I've got my integral symbol. Integral. This chunk right here is the square root now of, is the square root now of u. But dx gets replaced, and it gets replaced with du, and then it's like, what do I do with this x squared, right? I have to convert all my variables to u's. So if I have x right here, I can add the 1 over, and u plus 1 is equal to x. So x squared in here is u plus 1 squared. All right, moving on. We took u plus 1. We squared u plus 1, and we FOILed it out, and we got u squared plus 2u plus 1. And that is taken to times this guy, the square root of u, which is u to the 1/2 power. Okay? Integral du. Now we distribute. All right, when we distribute, we add the exponents. So 2 and 1/2, if we add those, is 2.5 or 5 over 2. Plus 2, this is u to the 1st power, and 1 plus 1/2 is 3 over 2. Plus 1, that's u. I need a u in there. And then u times 1 is u to the 1/2 power. All right, then integral, parentheses, du. Then we start to do our antiderivative, and this is where we kind of stopped yesterday. All right, so I have 1 over 5/2 plus 1 is like 5/2 plus 2 over 2, which is 7/2. So 1 over 7/2 u to the 7/2 power. Okay, plus this 2 is just chilling. I have 1 over 3/2 plus 1, which is 5/2, u to the 5/2. Okay, plus this guy is 1 over 1/2 plus 1 is 3/2, yes, 3/2, u to the 3/2 power. Okay, now we fix some stuff. So 1 over 7/2 is 2/7, u to the 7/2. Okay, plus this is 2/5, but we have it times 2, so that will be 4/5, u to the 5/2. This guy will be 2/3, u to the 3/2 plus c, and then last thing,
we put it all in for you.
U is x minus 1. So 2/7, x minus 1 to the 7/2 plus 4/5, x minus 1 to the 5/2 plus 2/3, x minus 1 to the 3/2 plus c. Now, if you really want to get really fancy, you don't want to get really fancy, but I'll write it out because you're whatever doing it like because you're writing it down anyway. The halves power is the square root, so this is technically the square root of x minus 1 to the 7th plus, you don't have to write it down like this, square root x minus 1 to the 5th power plus 2/3 square root x minus 1 to the 3rd power plus c. So if you want to put the roots back in there, that's what that means. Whatever. No. You do not need to do that, but I'm just showing you, like, maybe you like that better. I don't know. What?
I'm out of room. We can't.
Yes, dear.
If the bottom, like the denominator of the power is like 3, it'd be
the cubic root. Yes. Right. Okay, number 12
Hang on, I'm not ready.
is a whoopsie.
Well, the whoopsie is.
He is a weird
Would you
guy.
cosine X?
No. I would
You
think.
see what I'm thinking? Like you could put it in parentheses and put the 3 on the outside.
Yeah.
Yeah.
So that's my thought. Don't write this down. Here's what we're trying to evaluate, okay? And my first thought was to do u equals cosine x, right? And then this would just be u to the 3rd power, and we would call it good. Except du is equal to the derivative of cosine is negative sine, and we don't have a negative sign that appears.
Unless we multiply.
And we can't divide it over because, like, then I'll still have an x, right?
Wait, can X just be u? So cosine.
No,
u.
we'll never replace just x because then we could have just left it as x, right?
Yeah.
So I had to look real quick to see what they're doing. All right, so this is another, again, these are less apparent substitutions. These are like, would you know how to do that? All right, so here we go. Bear with me. Integral. They took this guy, cosine cubed, and they said, okay, cosine cubed is like cosine squared x times another cosine of x, dx. Okay? You separate those out into those pieces. Okay? Now, trig. You guys just got into doing this. I don't know if you guys remember this, but we have a Pythagorean identity in trig that says sine squared plus cosine squared equals 1, yeah?
Yeah, baby.
So cosine squared is equal to, if I bump the sine over, 1 minus sine squared x, right, is what cosine squared x. So I'm going to take that guy, okay?
So we got.
You do whatever you need.
I'm gonna have anything like this on the homework.
I'm not going to give you anything that's too terribly hard like this.
I looked at
I will make it a little bit more apparent.
Can we change him to be?
Okay? 1 minus sine squared x. I just subtracted the sine squared x over. Because we're going to take this guy and we're going to plug it in right there. We haven't even taken the derivative yet. And we haven't even assigned u yet. Woo.
Wait, so we have sine.
So integral, parentheses, 1 minus sine squared x times cosine x dx.
Okay. So
All right.
Can we change it to voila, voila.
Okay? I changed cosine squared to 1 minus sine squared.
Stupid pen. I think I'm running out of ink.
Now, next thing we got to do is u and du. Got any ideas what we're going to do for u?
R sine minus.
Sine.
Whatever.
U is going to be sine of x. Okay?
So smart.
What's the derivative of sine?
Cosine.
Cosine. You see him?
Yep.
Okay, so let's start substituting. I got my integral symbol. Whoop. This guy will become,
Cosine.
nope,
Oh, wait,
nope.
1 minus cosine.
1 minus,
Cosine
Sine.
squared.
No.
1 minus 1?
2. No. How would
what will
that?
sine squared get replaced with?
U squared.
U squared. That's what u is, right?
Wow.
Okay. And then cosine x dx. Do we have something to replace cosine x dx?
Du.
Cosine x dx is du. There you go. Oh, that's not so bad. All right. Now we're doing the antiderivative of this junk. What is the antiderivative of 1?
X.
In this case, it's u. Yeah. Right?
Yeah.
Okay. Minus antiderivative of u squared.
No, that's no. Yeah. 1/3.
1/3 u cubed.
Yeah, 1
Plus
third
C?
cube.
Uh-huh. Uh-huh. And then
Plug in.
sine x goes back in for u. So sine x minus, how do we write that? 1/3
Yeah.
Sine cubed x.
sine cubed x plus c. That is all. Okay?
That really
So that really wasn't that bad. Like the antiderivative was really pretty clean, but getting to that point, bleh, who would think to do all that junk? Yuck, yuck,
That's your
yuck.
answer?
That's it. There you go. Okay? All right. So, I'm just looking at homework. Number 1 is going to be pretty obvious. Do you see this guy? Your u? Do you see how his derivative is 2x? Yep, he's going to be pretty obvious. Number 2, you see this guy?
U.
His derivative is going to be not just
Wow.
x squared. His derivative will be 6x squared, yeah? Okay, so what do you have to do with the 6?
In front.
So you'll end up having like a
1/6.
1/6 thing happening, right?
1/6 integral sine.
Okay, all right, so write out your u's and your du's.
Yeah, no, wait.
Okay,
1/4 du. Right?
mm-hmm.
Wait, where are we getting 8, 9, 10?
What?
Oh, these ones.
There's the backside.
There's a backside.
There's the backside.
Did I tell you?
I tried to make these kind of a little bit. Yes,
I did?
you bet your bottom dollar.
I don't
Wait,
have
was
a
that the
bottom
first
dollar.
one?
Yeah.
You don't need a 1/6 on that guy. Oh, whoa, 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 whoa.
Yeah, I
Yes, you
do.
do. Yes, you do. Blah, 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 blah. I'm not
Like,
listening.
I don't know what
Okay.
you're
I'm
talking
not
about.
listening. I'm not doing it right.
Okay, I
'Kay.
got to the point where we plugged them all back in, and now we have to find the antiderivative.
Okay. Did you get, on number 2, before your antiderivative, did you get 1/6
Integral sign.
integral u to the 4th du? Is that what you got?
Yeah.
Okay. Now do the antiderivative.
So how do, oh, we have to do the antiderivative
1/6 is just
before I
chilling?
plug the jump in. I forgot to do
Yeah.
it. I plugged this up in before I took the antiderivative.
Uh-huh. Okay.
Okay. So 1/6. Is it 1/6 plus?
No,
When the
it's times.
times
Uh-huh.
right out of the parentheses.
Yep.
1/5,
Yep. So you can combine those to 1/30th.
5, and then du. Wait, du just becomes plus c, right?
When you take the derivative of it, or the whatever it is.
Yeah. When you take the antiderivative, it just becomes plus c. So 1/30th u to the 5th. Tell me. So 1/30th u to the 5th. Is it still u to the 5th, or is it u to 1/30th as well?
Does it look stupid if I do it like this? I wanna do it like this, except I make it 2.5 inches wide, which is fine. Inches wide, I don't know if it's very tall.
Use a different one. How many fingers is that?
Not enough.
Not
I
enough?
don't know.
Oh.
Just go the way you saw it. Let me put on. I like that way. Can we not just go that way?
This way, like if I do it like this?
It doesn't even matter.
I think it'll look fine.
Yeah. We're doing it.
Can I look for these? Or did I do it wrong?
Yes, 1/30th.
So 1/30th.
1/30th.
Plus C.
Whatever to the 5th, yep.
Tell me.
Would you like to see what I'm doing here?
Attempting to